Hello everyone, welcome back to my YouTube channel. This is Nihati from Sri Venkateswara College of Engineering, and today I'm here with a video on operators in Java. We'll be seeing the various types of operators here. So let's see the contents for today. In this video, we'll be seeing about introduction. We'll deal with the introduction, what is operators. Then we have the precedence and associativity. I'll not be going through the precedence and associativity, we just have a chart. And then we have different types of operators that we'll be looking into mainly in this video. After that, we'll conclude the video. So, what are operators? Operators are used to do operations on variables. So, Java provides many types of operators which can be used according to the need. They are classified based on the functionality they provide. They are the symbols used for performing specific operations. Operators make tasks like addition, multiplication, etc., which look easy, although the implementation of these tasks are quite hard. So, not just addition and multiplication, we have types of operators in Java like relational, logical, bitwise, shift, and etc. So all these will be saying one by one in this video. So next we have the precedence and associativity chart. I'll not be going deep into it, but precedence is nothing but the order in which the operations take place with the operators, and associativity is if you're going to do the operations from right to left or left to right. So this is the chart for precedence and associativity of operators in Java. So the various types of operators in Java are arithmetic operators, unary operator, assignment operators, relational operators, logical operators, ternary operators, bitwise and shift and instance of operators. We'll be seeing all these one by one now. So first we have the arithmetic operator. And what are arithmetic operator? Arithmetic operators are nothing but the operators that we use to do arithmetic operations. So that will have addition, subtraction, multiplication, division, and modulo. In modulo, it is nothing but when we divide two numbers, when we divide a number by the other, we have the remainder we get will be the modulo, will be taken as the modulo. So this one we can see with an example using a code. Here we have the code for arithmetic operator. We are taking a class name arithmetic. We are initializing a is equals to 10 and b is equals to 3, and then we are doing the operators. So this is the print statement, and this is the operators we are going to do. So a plus b, a minus b, a into b, a by b, and a modulo b is what we are going to see. We'll be seeing the output for these. So here, so what are we getting is 10 plus 3 is 13. So it will be a plus b will get the value as 30, and this will be taken as a plus b, printed as a plus b is equals to 13. Then we have a minus b, 10 minus 3 is nothing but 7. So a into b, 10 into 3 is 30. A by b, 10 by 3 will get 3. That is because we are taken as it actually is not just 3, it's 3 point something. So because we have taken the values in int, it will be shown as 3, and a modulo b will get 1. 1 as a remainder. When we divide 10 by 3, we're getting 1 as a remainder, so that will be taken as, so the answer for a modulo b will be 1. So this is about arithmetic operators. Coming to unary operators. The unary operators need only one operand. Here we had a plus b. Here we don't. In unary operator, we don't need two operands. We just need one operand. So they are used to increment, decrement, or negate a value. So we have plus plus, minus minus, and plus for negating and making a number as positive. Default is positive. So unary plus is not taken usually. Unary minus negates a value, that is gives the negative value of that number. Plus plus and minus are increment and decrement operator. So in that also, in increment we have post increment and pre increment. What are increment will be same? Increment operator is used for incrementing the value by 1. So plus plus, if you write I plus plus, it is I plus 1 will take. So that is incrementing by 1. There are two varieties of increment operators, post increment and pre increment. So post increment is nothing but value is first used for computing the result and then is incremented. So first the value is taken, then it will be incremented. In pre-increment, first it will be incremented and then the result is computed. Next we have the minus that is a decrement operator. For that also we have post decrement and pre decrement. Post decrement, value is first used for computing the result and then is decremented. In pre-decrement, it is decremented first and then the result is computed. Then we have the logical NOT operator used for inverting a Boolean value. So these are the unary operators. This one also will be seeing with the help of a program. So if we go to unary, so the program here we are initializing A as B and A as 10 and B as 10, B is equals to 10. Now post increment, what happens is A plus plus. What is the value we'll get? Post increment is A plus plus. So the value will be given first. 10 will be taking 10 and then it will be incremented. And then it will be incremented to 11. It will be plus 1, 10 plus 1. So print ln pre-increment, we're doing plus plus A over here. So already we have the value of 11. This plus 1 will be equal to 12. So that will be the value that is printing. So the first will get 10 and then the answer will be 12. This is the incrementing values. Coming to the post decrement. Post decrement is after that. First we have 10, then we'll do minus minus. So 10 will be taken first. After printing 10, we'll be decrementing it. That will become 9. Okay. So this will become 9. And after that, pre-decrement, minus minus b we are taking. So first it will be decremented. That is 9 minus 1. That we'll get 8. So first one, the answer will be printed as 10 and the second one will be printed as 8. So we have 10, 12, 10, 8, which is the answer we're supposed to get. So after unary operator, we have assignment operator. So an assignment operator is nothing but just equal to. Okay, so we are assigning the right hand side value to the left hand side variable or whatever is there on the left hand side. So this is assignment operator. Assignment operator can even be used as combination of other operators like plus equals, minus equals, into equals, divide by equals, modulo equals. So the main thing is if you're writing plus equal to, it is like a plus equals 5. Here, for example, we're taking a plus equals 5. It is nothing but a is equals to a plus 5. So this is how the assignment operator works. So plus, it is used for adding, and then assigning the variable to the left. Minus equals, they'll subtract first and then they'll assign the value to the variable. Into equals, division equals, modulo equals, everything does the same. They first operate and then they assign the value to the variable which is on the left hand side. So the program for assignment operator, is, so now here we're initializing f as 7. After that, f plus equals 3. So what happens, if we actually write it the full thing, it will be f is equals to f plus 3. F is nothing but 7 is already taken. So 7 plus 3 is 10. This 10 will be given to the f value. So f will be printed as 10. Here f minus equals 2. What we'll get is 7 minus 2 is equals here 10. Here f becomes 10 after doing the operation first one. So f value is 10. 10 minus 2 is 8. This will be given to the f value. So we'll get 8 over here as answer. After that, the same way we'll do for the remaining. We'll get 32, 10 and 0. These are the outputs we'll be getting for the assignment operator. Next, we have the logical operators. No, we have the relational operators. These operators are used to check for relations like equality, greater than, less than. Or it can even be used as combination again, like greater than equal to, less than equal to, not equal to. These are the relational operators we have. They return Boolean results after the comparison. They compare the result and then we get the Boolean result, that is true or false. And these are used in looping statement as well as if else condition statements. So the relational operators are equal equal, that is equal to returns true if the left hand side is equal to the right hand side. Less than, if it will return true if the left hand side is less than the right hand side. Less than or equal to returns true if the left hand side is less than or equal to the right hand side. So basically there's a comparison going on and then it returns result as true or false. Okay, so then we have greater than and greater than equal to. Similarly, we do these also similar to that. So program for relational operators. So in relation operators, we are taking class in relation. We are giving A as 10, B as 3, and C as 5. So what are the desired outputs? Will be saying A greater than B. Is A greater than B? Yes. So we'll get true as the answer. A less than B? No, it is false. So we'll get false as the answer. Then we have A greater than equal to B. Because 10 is greater than 3, it is true. So again true we'll get. A less than equal to B? No, false. A equals C, which is not true. Again we'll get false. A not equal to C. Yes, A 10 is not equal to 5, so we'll get true. So this is our relational operators. We have the logical operators next. Logical operators are used to perform logical and logical OR operations, a function similar to AND gate and OR gate in digital electronics. Java also has logical NOT, which returns value when the condition is false and vice versa. So conditional operators, these are the operators we have. Logical AND returns when both conditions are true. Okay, AND returns true only if both the conditions are true. Logical OR returns true at least if one condition is true. Logical NOT returns true when a condition is false and vice versa. So this is logical operators. Program for logical operators. So, so the program for logical operators. This is a program for logical operators. We have x is true and y as false. We have taken x as true and y as false. So is x and y. So true and false. So that will come as true and false, which will become false because for and operator it will return true only if both are true. So we'll get false as the answer. X or y, that will get true because any one is true, it returns true. So we're getting true. Not x, because x is true, so not x will become false. So we're getting false over here as answer. So next one, we have the ternary operator. The ternary operator is a shorthand version of the if-else statement. It has three operands and hence the name ternary. The general format is condition, question mark, if true, if false. So we have a condition over here. If this condition is true, this will be executed. This statement will be executed. If it is false, we'll have this statement executed. So this is about ternary operator. So again, we'll have a program for ternary operator. This is the program for ternary operator. Int x, y, x is equals to 20. We have taken x is equals to 20, y is equals to x minus. This is the ternary condition we are taking. Y is equals to x is equals to 1, question mark, 61, 90. If this is true, it will print 61. If it is not true, it's going to print 90. The system dot print ln value of y is. So is this true? No, because y is not equal to x is equals to 1. So we'll the value that will be printed will be 90 because since this condition is not true, we'll have this 90 printed. After that, y is equals to x is equals to 20. And first we've initialized x as 20 already. So this statement will be true and hence it will print 61 as the answer over here. So this is ternary operator. After ternary operator, we have the bitwise operators. These operators These operators are used to perform the manipulation of individual bits of a number. They can be used with any integer types, and that is bitwise AND operator returns bit by bit and of input values. Bitwise OR returns bit by bit OR of input values. Bitwise SOR returns bit by bit SOR of input values, and bitwise complement operator returns one's complement representation of an input value, that is with all bits inverted. So we'll be seeing this with an example. So the example for bitwise operator we have is this. So we run this program. So first of all, we have taken D as 0B1010. 1010 is the binary literal for the number 10. And then we have E as 1100. 1100 is for 12. So if you're printing D and E, we're going to get 00, and we're doing AND operator here. So 00 will have 0 over here. 10 again to be 0 because In and if both are true, only true will come. So we'll get 1 0 1 0 0 0, which is the binary literal for 8. So we'll have the answer printed as 8 over here. Next for OR, we'll have 1 1 1 0, that is 14. And after that, we have the SOR operator. We'll have 0 1 1 0. This is 6. Okay. So we have all these done. And now for this binary, or what it is, the bitwise NOT operator, here 0 be 1 0 1 0. 0 be 0 1 0 1 0. That is this one. 10 will be taken as 1 0 1 0, but 32 bits will have over here 0 0 0, which will not usually take into consideration. But for not, since we are taking the complement of these also, this will be taken. So we'll have the complement will be this, and this will evaluate to minus 11. So minus 11 will be the answer for not B. So this is all about bitwise operator. The next is a shift operator. 8-1 is a shift operator. These operators are used to shift the bits of a number left or right. General format, number shift operator, number of places to shift. So we'll see this with an example. We have left shift and right shift. Left shift, what it does is shifts the bits of the number to the left and fills 0 on the void as a result. So, and right shift, sign right shift operator shift the bits of number to the right and fill zeros on the voids left as result. So we'll see this with an example, then you'll understand more easily. So the program for shift operator. So this is 8. In A is equals to 8 we are taking. If we are shifting A, this is left shift. We want to shift it to the left side. So on the right side, if we are shifting to the left side, we'll be adding zeros to the right side. And if we are shifting to the right side, we'll be adding zeros to the left side. So we'll see 8 is nothing but 1 0 0 0. So if we're shifting to the left hand side, we'll be shifting and there will be 2 places left. So there we'll be adding zeros. So here the binary literal will become 32. So we have 32. When we're shifting to the right hand side, we have the number is 100. If we want to shift it to the right hand side, so here we'll be adding 2 more zeros, and these zeros will not be calculated and it won't be calculated. So here we'll be having 2 as the answer. Okay. So this is about shift operator, left shift and the right shift operators. After that, we have the instance of operator. The instance of operator is used for type checking. It can be used to test if an object is an instance of class, a subclass, or an interface. General format is object, instance of class, a subclass, or interface. This also we have a program which will show us how it works. So this program So in instance of operator, we have a class name person, we have a subclass name boy. This is inheriting the class person. So boy extends person will be writing, then implements my interface. There's an interface, my interface here. So and in the class person, we have object one that is implementing person, that is the main class, parent class. Boy is an object for the object two is for boy, that is the subclass. So object one instance of a person. Object one instance of person, is it an instance of person? Yes, so it will return true. Object one instance of boy. No, because boy is a subclass and person is the parent class. Object one is an instant. Object one is an object of the parent class, so it won't be applicable to the subclass. So it will return false. Object one instance of interface, again no, because object one is with the parent class, not so it won't be there with here. So again, it will return false over here. Object 2 instance of person. Yes, because this is a parent class. Object 2 is from the boy or from the subclass, and subclass is inheriting the person class. So we'll get true as the answer. Object 2 instance of boy. Yes, again we'll get true. Object 2 instance of my interface. Yes, true, because it is implementing my interface. So this is all about this one, instance of operators. So we've taken all the 9 operators, we've seen how it works. So that's it for the video. And for conclusion, operators in Java provide a concise and readable way to perform complex calculations and logical operations. It also saves time by reducing the amount of code required to perform certain tasks. Using operators can improve performance because they are often implemented at the hardware level, making them faster than the equivalent Java code. So this is all about the operators. We've seen about arithmetic operator, assignment operator, relational, logical, bitwise, shift, ternary, instance of, etc. So these we'll be using to make our work easy and to make the calculations more easier. So this is all about the video. Thank you everyone for staying with me till the end of the video. Hope you liked and learned something from the video. So please don't forget to share, like, share, and subscribe to my channel. Thank you so much.